Hi, everybody. I would like to welcome you to this DevLab today, Machine Learning on Autonomous Database with Charles and Lily. Today, for attending this workshop, we have a free trial for you, an exclusive free trial that they'll go into in more details as we get into it. The event is being recorded, so you'll receive a copy following the event. And if you have any questions, please let us know in the Q&A box and we'll get back to you live or through the Q&A panel that we have available. Without further ado, I shall hand over to Charles, who's going to start today.
Thank you, Jane. Welcome everyone to today's webinar. To start off the webinar, we're going to quickly look into the topic that we're going to present today, which is the Oracle Machine Learning with the Autonomous Database. And this workshop is pretty much to showcase the powerful tool that is being built into the Autonomous Database, which is the Oracle Machine Learning. And inside this workshop, you'll see that we have a scenario where there is some data relating to bank transactions, especially on the credit card, where we want to understand which customer is able to pay the installments to ensure that would not incur losses to the banks. So by utilizing the machine learning, they'll be able to identify which will be the suitable customers that the banks will be able to target to ensure that they would be able to get maximum profit out of it. Now, the objective of this workshop is mainly, the start of it is to provision an autonomous database and load the data into ADW. Then we are going to create a machine learning model inside the database. And once the machine learning model has been created, that's where we start to migrate this model into an autonomous transaction processing. We would assume that will be the production database instead of the development database in ADW. And once the model has been migrated, we'll be able to do some prediction inside the application itself. So of course, for the prerequisites, we will require to have an Oracle Cloud account. And I'm going to show you quickly how you will be able to create a free trial account. So inside this particular lab, they'll be giving you some steps in terms of how you can create your trial account. And you'll be able to see that there are two different types of offers. One is the always free approach along with a 30-day free trials that comes include with $300 of free credits, right? So moving on to step one of creating a free trial account, all you need to do is to hop into this website, which is the oracle.com/cloud and /free. Over there, you'll be presented with a registration page as what you're seeing right now on my screen, right? Exactly as it is, where you could select your country and territory, and you're going to put in your first name and last name along with the emails. And once you submit your CAPTCHA and all that to verify your email, you'll be able to move on to create a cloud account. And eventually an email verification will be sent to your mailbox. And once you click on the link, you'll be able to validate your email and move on with all the steps below, where you can choose a password, you can enter your company name, set a cloud account name, and along choose a home region. So we recommend that in terms of the home region, that since it cannot be changed once you have signed up, it's best that you choose a home region that is near to your location. So with that, you would have a much better in terms of the connectivity. Since if it's closer to your network, then in terms of the responsibility of the network, you'll be much better compared to choosing a home region which is far away from where you're based off. And eventually we can click on continue and add on your address information and so forth, along with the mobile verification, and then you can go ahead and click on the agreement to agree to start your free trial account, right? Then eventually, once that is done, you will notice that you have a cloud account. So this particular cloud account is pretty much your cloud account name, and you will require this name to log into your account. So eventually, in step 2, you see that it will ask for a cloud account name. So you just pop that in to the cloud account name and click next. And it will ask you to sign in using the Oracle Cloud Identity Service. And it will show you your username and also the password. So this is where you put your email address and along with the password that you have set up earlier and click on sign in, right? And once you are in, you would see a very similar page, which is the Oracle Cloud that you're seeing right here. So right now, I'm just gonna hop into my account and you will see that this is the same familiar graphical user interface that you're seeing right now. And you can see that there are a lot of different ways you can get started, but for today's session, I'm going to hop into the Oracle database and head on to the autonomous database, right? And what happens is once we are inside the autonomous database, this is where we can start to provision some databases, right? And the first step of the lab is actually to create an ADW instance. So once you're in here, you would see that there's already a few different databases that has been created. But just to show you how that works, I'm going to click on the Create Autonomous Database. And you can see right now, it would ask you to key in a display name and also a database name. So I'll go ahead and put a very simple name, testing 1, 2, 3, right? And I'm going to do the same for the database name. And moving along, I'm going to select the database data warehouse, right, as a type, along with shared infrastructure. In terms of the administrator details, this is where you can set your password for the admin username. And I'm going to go ahead and put a password there. So once I have put in my password, the next area they will ask you is to choose your network access. So in terms of flexibility, we will select secure access from everywhere compared to a private endpoint. As a private endpoint is mostly best suited for large enterprise organizations, but they want to keep their traffic confined to within the organization's network. And eventually, we would go ahead and sort of choose license included to have the license included for autonomous data warehouse, right? And once that is done, we're good to go and we can create the autonomous database. So quickly, once that has been created, it would then pop back to the previous page here, and it will show you some of the databases that will be created. Initially, it will start off with an orange circle, and once it has been completely provisioned, it will show you the green circle, right? So the same goes with creating an autonomous transaction processing interface. It's just that when you try to create a few options here, and for today's session, it's either confined to the data warehouse or the transaction processing. So the difference here is that for data warehouse, it's mainly, for most of the time, it's for the analytics workload where you have data coming in batches rather than real time. Whereas for transaction processing, it's more suited for ongoing transactions that's coming in. For example, credit card transactions or bank transactions and so forth. So eventually what happens is that most of the main applications would then be linked to this transaction processing databases, and this would allow you to quickly get and transfer data within the application, right? So once we have created the database, we can go ahead, go into one of these databases, and it will give you quite a number of information here, right? And one of the key things that we want to showcase is at first in terms of how we could create users. So if we click into this Oracle ML user administration, it would then give you the access to add-on users here. So you can, create users and, to add in users for your machine learning usage, right? And eventually what happens is that once you have created the user, now in this case, in our lab here, what we're actually showing is that it is require us to create the ML user, right? So if we were to look into the lab guide here, you would see that it is asking us to create the ML user in ADW. So what it does is like what I've shown earlier, to go into the tools, click on the Oracle ML user administration. And once you're logged into it, you have the option to create a user. So I've actually created the ML user. And once it has been created, the ML user would then be listed in this particular interface here. Now, what happens next will be more important, which is to grant the access to the ML user so that you are able to push or load data into the database. So if we were to look back in this particular autonomous data warehouse, you'll see that there's an option called database actions, right? So I'm going to click into the database actions. And what it does is it would ask you to add in your username. So what I'll do is I go by the admin first, because every time a database has been provisioned, the admin username will be provisioned, right? And once that is done, I'm going to go into, put in my password. So once you have logged into the admin username, it would show you a number of options here, right? So what we're going to do is we're going to start off with the SQL, right? I'm going to click into the SQL, and it will actually bring you to the web SQL developer, where you could, put in some of the codes to execute it, so that the ML user would then have the permission to, execute and upload data into it. So back into this particular guide here, you would see that once you have logged in, you head on to the SQL. Then you have some SQL codes here where what it does is it would target this particular username, which is ML user, and allows some permission so that ML user would then be able to get access to the database actions, right? So it's just as simple as copy this particular SQL code, head on to the database action here, and then you could execute the code by clicking on this run statement, right? So once that has been done, you would get a confirmation by saying the PL SQL procedure is successfully completed, right? Then eventually what happens is down the next few steps, especially step number 8, there is another option where it gives you where we need to sort of execute this code, where you grant storage privileges to the ML user. So I'm just going to go ahead and do the same here. I'm going to click on run statement. And again, it would give me a confirmation that the user, ML user, has been altered, right? So now we'll be able to sort of start, putting in data into the autonomous data warehouse. So if we were to go on to the next few steps, we actually have a set of data set that is being uploaded into this guide, which is the install.zip file. So you can go ahead and download this zip file, and you can then unzip it and sort of push the data into the autonomous data warehouse. So under step 6 here, you will see that now we are going to go into the database actions again. So what I'm going to do is I would just go into the database actions again, and I can now log in as an ML user compared to using my admin user, right? So I'm just going to start going in. And very well, this is where we will be required to key in a password for the ML user as well. So I'm just going to click sign in. And once we reach to the database actions, it is the very same familiar web page that you've seen earlier. It's just that this time around, it's being logged in as the ML user. So now you do have the privilege to use the database actions via the ML user username, right? And eventually I'm going to click into the data load, and it would give you a few options here. One is a load data. Either you want to load the data, you want to link your data, or you want to feed your data, right? But in this case, we're going to do a more simplified approach, which is to upload the data from a local file. So I'm going to go ahead and click on next so that I can load a file up here, right? So now it asks me to select a file. So I'm just going to go ahead and select one of the files that I'm getting from where I've actually downloaded. So we'll see that there is a number of different data, right? But for this case, I'm going to try to load the credit scoring, right, of this file. So once I click open, it would then start loading the data up. And it will ask me whether this is the file that I would like to load in. And if yes, we could go ahead and click on the play button here, right, to start the loading process. So it's going to run the job to load the data into the autonomous data warehouse. So it would take a little bit of a while to upload the data. And once it is being uploaded, it would give you a confirmation in terms of how the data is being loaded. So just quickly to show you, inside the steps here, you would see that once you click on run, it would then start to load the data, and it would give you, the progress meter on your left. And if we were to check back, it's taking a while to load, but it is progressing, right? And eventually what happens is once it has been completed, you will get a tick here. And the good thing is once you have loaded your data, you can then go ahead and check, just to have a look what sort of data has been loaded in and what are the columns and so forth that's being created. So back in those days, when you try to load the data, you will first need to create a table, define the table names and so forth. But now you just need to, put in the data file into it, and automatically it would detect the columns and create a table with the columns as well for you without needing to, specify it individually, right? So if I were to check back in the progress, it's halfway there. And eventually what happens is that once it has been uploaded, like what I was saying earlier, you would then be able to click onto the hamburger menu here and eventually go into the SQL, right? So eventually, once we do that, you will see that, again, it will bring us back to this SQL page here, right? So this is where you could, check in terms of what are the tables that's been created and query on each and every of the tables to check what are the data that's being loaded into it, right? So eventually what happens is we would need to sort of check whether the data has been loaded or not. So yeah, it's almost there. And yeah, like what we're seeing here, these are some of the menus available once you click on the hamburger menu. So you have all these particular areas where you can make use of. For example, either you want to use the SQL, the data modeler, REST, JSON, and charts, right? So now that we have finally finished uploading this data, I'm going to go ahead and go to the SQL, right? And in this particular SQL, the same familiar graphical user interface, you would see right now there are two tables. One table which I initially tested out, and this is actually the table that we have currently loaded in. So you could quickly, do a quick look in terms of what are the contents of this table or the data that we've loaded in. You can drag and drop, right? And it'll ask you a few different selections. Either you want to do a select statement or update, delete, or insert statement. So of course, we're going to go with the select statement. Once we click apply, it would then show you all the columns available inside this table, right? Which is with the select statement in tag. So I'm just going to click the play button here to run the statement. And soon it will show us the data that is available. So as you can see right here, based on all the columns that's been listed here, it would then be shown along with all the data sets, all the data that has been loaded in, right? So we can see this is actually a credit score for a particular customer based on the demographic and what are the loan types available and so forth. So we'll be using this particular data set to do a little bit of machine learning, create the models, and eventually move on to the next step in this lab, right? So what I'm going to do next is now that we have completed this particular area, we can move on to the lab 2, right? Inside the lab 2, what it does tells us is that this is where we can create the machine learning model, right? So it will give us an option where you can predict some of the results of this particular notebook. So inside the same particular autonomous data warehouse, like what we've seen inside here, there's an option called Oracle ML User Administration. So like what we have seen previously, this is where we create the username, but now we can also log into the interface where we could look into the notebooks. So I can go into the Oracle Machine Learning notebooks, right? Where I can sign in using my ML user. So what I'm going to do is I'm going to key in the user credentials and also the password. So this is how the Oracle Machine Learning looks like, where it has the capability where you could put in the notebooks along with your ML codes into it. So you have things like the notebook where you could, create a notebook here. So inside these notebooks, you would have, this is where you could create your notebook, right? You'll be listed here. There are two options. One is either you create the notebooks from scratch, or you could also import a notebook, right? And if you were to look into the menu here, we do have quite a number of templates and examples as well, right? Where if we were to go into the examples, you would see that there's a whole list of templates where you could explore or go into. And in terms of the coding language, it is based on the SQL, but also we support Python and R as well. So if you were to see some of the titles here, which is OML for PY, that indicates that this is example for Oracle machine learning that is using the Python language, right? So back to where we are, you'll see that once you have created, opened your Oracle ML user administration, you will see the same particular login flows that I've shown you earlier, where you have to initially put in an admin along with a password to create, to get into this page and sort of start creating an ML user. So in this case, now that we have the ML user that's being created, we will need to click on the home icon on top of the page in order to land into another page where this is where we can use the ML user to sign in, right? So once we sign in again, we'll see all the examples that we see right here in terms of how you can check out the Oracle machine learning notebooks. And for example, these are some of the templates that I've shown earlier where you can also go into and have a look, make use of all the examples to do your coding and machine learning. So the next step is essentially to, click on the create button so that you could now start to create a notebook where it will show you an ADW notebook. You could put any name that you want. And once you click OK, it would then appear right where I've shown you, which is under the notebooks, right? So this is where all the created notebooks, it will be listed right here. And even is the same for using the import function. So again, it gives you the flexibility to import and export all your notebooks that you've created right here. And if we were to look further, well, you can now start to head on into the notebook and you would see that it would give you this particular user interface where you could sort of click into the gear and it would ask you to, select the interpreter binding where, you have a few options here. One is the low, medium, high, right? And also the percent MD. So all these particular options here should be selected. And what does low, medium, high means? So essentially what happens is that inside the autonomous data warehouse, you have the connectivity to this notebook. So this notebook would then would have the mode of connection to the autonomous data warehouse. In this case, you have the low mode, medium, and high. These are the options for the parallel options for connectivity to this particular notebook. So in any ideal scenario, if let's say you're inside an organization with average number of users, we recommend that you go with the ORCL medium so that it has I would say it has the most number of parallel in terms of the speed as well. So that will give you a balance in terms of the speed and the number of parallel for each particular user that wants to execute queries to the autonomous database at the same time, right? So for high, it would be more towards confined to a few users, but their query is pretty heavy to the database, and that's why they will require more bandwidth for that particular connection. Whereas for average user, the ORCL medium option is fine. But in this case, just for simplicity, we would be selecting all of this because just to showcase, it will also be able to fall back into any of this connectivity as required when it detects the traffic in the database. Now, eventually, you will see that you can now sort of go into your notebook and you see right here, what is the %MD? That indicates the markdown language, which is used for the formatted text, where else the %SQL, this is where you would execute the, or run the SQL statements. You would see that you can only run one statement per paragraph, right? Or otherwise you will be requiring to use a script. And that's where you will select the %script here to run multiple SQL statements. Now, this is where things get interesting, where you sort of start off with the notebook, where you put on the %MD and put a particular note into the notebook and hit on the play button here. So what that shows you is that it would then execute this particular script, but because these are just text, right? So it would just show you a narrative of the text that you just sort of entered earlier on. And also, once that has been executed, you'll notice that this layer on top here, it would show you the script, whereas the layer at the bottom here would show you the result. So sometimes the developers would just want to see the result rather than looking at the script. Then you could go ahead and click into this particular icon here, which would then close off the scripts here. So eventually, once that has been clicked, which is the arrow in button, then you would see that it will just only show the results of this particular script that we have sort of executed. So eventually what happens next is that we can then go ahead and test it out, put an SQL, %SQL here, and start querying from the table that we have loaded in. So as you can see earlier, we actually loaded into the ML users schema. So when we do the selection, do the select statement, we will need to put in the username, which is the ML_user dot table name. So this is actually the table that has been created. And the criteria here is to include a restriction where we have row numbers less than 100, meaning it will be around 99 row counts. So you will see 99 rows of results being listed here once you click on the play button. And you will see this is how you could sort of customize it by clicking on the gear button on top to show a title. So right now, once the gear button has been clicked, you would then show a title on top here, which is untitled, and you could put it into any title as you see deemed fit, right? So this is how you could utilize, once you have created the notebook, you can go around and put in some queries in here, play around with it, and eventually look into the results and see how that works. And eventually, in this particular results that we see here, we have the flexibility to quickly transform to either graphs or pie charts and so forth. And as you can see right here, I've actually sort of created into the bar graphs, right? And if you were to click into the settings, you will see that you have some available fields here where you could do some sort of grouping. So it can be in terms of the keys, the groups, and also the values, right? So in this case, the initial graph that has been shown here, you have customer ID in keys and you have age sum in values. You can go ahead and drag and drop this the fields that's available to have a more accurate representation of what the graph should actually look like. So in this case, I'm going to put occupation as a key, and the values customer ID. This should be actually count, so that you can count the number of customer that is fall under a particular occupation. So eventually it will show you the results based on the fields that you have selected right here. And again, you can go ahead, and move on to the next step where we could sort of import an ML notebook into it. So in step 3, you will see that I'll be able to import an ML notebook. So on top of here, you'll see that you have an option for you to download the notebook, which is targeting customer that complete all the payments, which is actually in a JSON format, right? So inside a JSON format, it is very, I would say it's pretty universal, and one could, download the notebook and have it shared to other teammates in terms of how they want to analyze the particular notebook. So again, if we were to go into the Oracle Machine Learning, we can just click into the import here, and I'm just gonna change this up, right? And I'm gonna set it to a different name. So I'm just gonna upload this notebook here, and within a few seconds, the notebook would then be created. So back into where we are seeing right here, once the notebook has been imported, right, it would then appear at the same area. And then we can go in and explore the notebook to understand how we could, start creating a machine learning models. But in this case, because this is a very large data set, so in terms of the particular interpreter binding, I'm gonna just select Oracle High along with the %MD, right? So once you have the notebook, you can go ahead and click on play. So what it does is it will ask you to run all the paragraphs. You click OK, and it will start to create all the analysis that is available inside this particular notebook, right? So once you have created all this analysis, you could then go ahead, and have a look in terms of what is the ML notebook and how that works. So this step 4 kind of shows you what is this notebook about. So you actually have like using back the same data set that we have loaded in, which is the credit scores. You would then sort of scan through the data to understand which customers, what category are they fallen into. Either they are the good credit customers or they are other credits, right? So of course, we'll also be able to look what is the demographics of the customers in terms of the occupation, the marital status, and what is the maximum credit card amount that's being spent for each and every customers. And based off of that, we'll see whether these are the good credit customers or they are fallen under the other credit. And based on all these particular data, you can then run a number of different graphs to understand your data better, right? And eventually we would come up with a few attributes that we think that is important to identify the influence that it has for that targets the attribute that we are interested in. And eventually we can use this particular notebook to create additional data by splitting them into a build test model. So there'll be, sort of like 60%, which is a trained data set, while another 40% of the data will be used to test the data. So what it does right now, we'll be sampling 60% of the data from the initial data set that we've loaded into, and then we will do a little bit of sort of training into it and build the ML model. And once we have finally, built the model, you can then sort of compare the models, just to understand what is the performance of the models. And eventually we will then be able to pick one particular model that has the nearest accuracy to the test data that we are going to test in terms of the prediction of the outcome for that particular attribute. So once we apply the model to make the predictions, you'll then be able to see and segregate some of the predictions from customers with good credit versus with the other credit in terms of the likelihood of the prediction in terms. So in this case, we'll see if the percentage is more than 50%, they will fall under the good credit, and we'll then be able to verify the results based on the test data that we have split into, right? So eventually, based on the final table, we'll then be able to see the probability of the good credits for these particular customers. So of course, we would prefer to filter out, the probability of customers, which is towards the higher percentage, which is higher than 50%, that will give you a better conviction. So eventually, once that is done, we can now start to take advantage of this machine learning model and push it into the autonomous transaction processing. And in this particular step, I will pass on to my next colleague, Lily, to move on to the next few labs. Lily, move on for you.
Okay, thank you, Charles. Let me share my screen. Good afternoon, everyone. I'm Lily, and today I walk you through for the lab 3 and the lab 4 latest. So for this lab 3 and lab 4, as you can see that the link that we share in the chat or Q&A, you can access to that link. It will browse you to the information of this exercise. And please don't forget to download the necessary data that you will need to do the lab later on. You can go to lab 1, step 5 to download data install.zip. You need that data later in these 2 labs. Right. Okay, let's talk about lab 3. In this lab, you need to do 2 activities here in ADW or Autonomous Data Warehouse and in ATP or Autonomous Transaction Processing. In ADW, what you need to do is you need to log in as ML_user to export the model to a temporary tables. After that, we will download the credential wallet file and upload it into the object storage. That's the ADW part. For the ATP, we will need to create a new user schema, ML_user. We will then grant that user an access to SQL Developer Web and to the storage. Next, we will then create a database link between ADW and ATP so that we can copy over the machine learning model from ADW to ATP. After that, we will log in as ML user and import ML model. Then lastly, we will create the virtual columns on the tables, and we will show that you can apply the models to the row in the tables later on. All right, if you click the link of this exercise, you go to lab 3, step 1. First of all, they will ask you to export the machine learning model. So like what Charles has done in the previous lab, lab 1 and lab 2, right? He already created the machine learning model in ADW, Autonomous Data Warehouse. We will then go to that Autonomous Data Warehouse, then try to export that. Let's start. You go to ADW console, you open database action, and you log in as admin. You log in as ML_user. Okay, we go to SQL. So what we need to do is we need to create a temporary table to hold our data mining model. Then we check our mining model that we already done. Okay. After that, we will run this command to export the ML model into the temporary table. All right. We then check with the length to see whether the model was exported. If you can see that there is some length appear on the screen, it means that the model is exported. Okay. Next, step 2. We then create ML user in ATP, autonomous transaction processing. Okay. To do that, we go to ATP. We click on the tools. We click ML UI. First, we log in as admin. From this UI, you click create. Name your username, which is ML_user. Tag to your email address. Set up your password. Click create. This is in machine learning inside autonomous transaction processing. You can see on the screen, we have a new username ML_user here. Okay. Next, we will then go to SQL developer web. We log in as admin first. What we want to do here is we want to enable the ML_user that we created just now in OML. We want to enable this schema here. So let me run the script. This is to enable schema ML_user. After that, we then grant the storage privilege to ML user. Okay. So next, we are going to do step 4, 5, 6 together. Step 4 is to download ADW credential wallet. Step 5 is to create an object storage bucket and then upload your necessary data there. Step 6 is to generate auth token. Okay, we go to ADW console on the DB connection and click download wallet. You need to enter your admin password here. Click download. It shouldn't give you a zip file of your ADW credential. Here is a zip file of your wallet. You need to unzip it. Okay, take a look inside. The file that you are going to use later is cwallet.sso. Okay, next, we are going to object storage. So we browse to the storage. Click bucket. Click create bucket. Name your bucket. All right, Just now, the file that we need to upload here is cwallet.sso. So we click upload button. We drag and drop file to here. cwallet.sso. Click upload. Okay. You need to save your object URL over here because you will need to use it later. Copy that. Okay. Now we are going to generate auth token. You go to your profile, you click your own user. Scroll down on the left-hand side, click auth tokens. Click generate token. Name your token. Click generate token and copy your token here. Let's paste in the notepad first. Okay. Then don't forget to copy your user as well, which in this case is Oracle Identity Cloud Service / my email address. Okay. Now we have the necessary information for the next step later on. Okay. Next, we will then copy machine learning models between ADW and ATP. In this case, we need to go to ATP and log in as admin. What you need to do is to create your credential. First, you upload your user and the token. Your user is what you copied just now, the Oracle Identity Cloud Service / your email address. The password is your auth token. Okay, we then run this command. Next, we then update the credential of our ADW. So in this case, I'm gonna use username admin and my own admin password here. So we run this command. Okay, then we need to tell the ATP what is our object URL, which we already saved from the previous step. Update it here. We run this command. This is to get the object from the object storage into the data pump directory here. Next, we will then create the database link. What we need to get information further is from the wallet zip file that we just download from ADW. We go to tnsname.aura. The information that we need here is like host, service name, and SSL server serve. So host is this one. We copy it. Okay. The service name, you can find it from tnsname.aura. So the service is this one. Okay. Let's extract SSL server from here to here. Okay, let's run this command. Let's check whether our database link work. Yep, it's work here. All right. The next step, after we already built the DB link together between ADW and ATP, the next step is for us to copy over the tables from ADW to ATP. So we will copy tables credit scoring underscore 100K and the table temp to ATP. So I run these two commands. The two table already copy over from ADW to ATP here. All right. Next, we will then import ML model. We need to log into our SQL developer web as ML underscore user inside ATP here. First, we create the temporary tables. And then we check the mining model. Let's test with some data. This is to show that our model is working fine. Then we want to create an additional column called likely underscore good credit percent. This one, please make sure that there is no duplicated columns to avoid yourself to get any error. Yep, the new column already added, likely underscore good credit percent. Let's test whether it's working. Okay, you can see from the result that we have a new column called likely good credit percent here. It is already created and apply the machine learning model here. Okay, now we are going to move to next lab, lab 4. In this case, what we will do in ATP, autonomous transaction processing, is to import the data to set up with this lab. Then we will import the APEX application from the file f100.sql. Then we will review the application to see how you can make prediction on the fly. Lastly, you will expose your machine learning model as a REST endpoint so that any other application can consume it. Okay, let's go to lab 4, step 1. First of all, we need to prepare some data in this ATP first. Okay, you click on the data loading. We want to upload customer name. You just drag and drop the file here. Then we click next. update your data type and the length accordingly. We'll use number for customer ID and change the length to 6. Then first name and last name, we just change to 100 each for the length. Click next, then finish. This one, they will create you a new table called customer underscore name with the data loaded inside here. Okay. Next, we will create a view that combine the names with credit scoring together. After that, I will create tables called upload customer. It's just a blank table first with the name of upload tables. Make sure that there's no duplicated columns in your commands to avoid getting any error. Okay, my new table upload underscore customer already created. All right. Okay, next step. So we want to start using the Apex application that is attached to this autonomous transaction processing. We will import the file f100.sql file to create the application using Apex. After that, we will show you how to run application and then review on the fly prediction and scoring. Okay, from ATP console, you click Tools. On the right side, you click Open Apex. First of all, sign in with your admin password first. Okay, we need to create workspace. This one will link the database user to ML underscore user. Name the workspace with ML underscore credit underscore app. Right, click create workspace. Okay. Sign out and sign in again with ML underscore user. Okay, I will sign in again. Workspace is ML underscore credit underscore app. The username is ML underscore user. Put in your password. Then you click sign in. All right. This one just to update your email address here. Just map to your email address. Apply change. Okay. We want to create a new application from the file that we have it for this lab. So we go to App Builder, click Import. You need to drag and drop the data here. The data that we're going to use is f100.sql. Click Next. Install application. Click Next again. And then install. Click Run Application. Log in as your user ml_user. So this is the Apex application that we create from the import file f100.sql. Okay, so let's check out the customer walk-in. Let me try the last name with Parker. And then let's test with Brooke. Here you go. The credit prediction in this case is other credit. So you are doing on the fly prediction right now. Let's check out other tab. So I'm gonna check out review uploaded customer, which you're not going to see anything here because we not yet upload any data here. This is also will be a blank because there's no data here. So what we need to do is to put in the data. We go to SQL Workshop, we go to Utility, then we go to Data Workshop because we want to load the new data here. We click Load Data. So I'm going to drag and drop the file, upload customer here. What I'm gonna do is I want to add this data into an existing table, which I already created in the previous step. Okay, I will choose existing table up there. Then I choose the table upload data that I already created. Okay, this one just to make sure that you are mapping columns to column correctly. So make sure that you double check before you click load. Okay, in this case, we scroll down. The missing one is residential status. We then map to residential status. Click save data. All right, then we click load data. All right, so now we already add in some information to our upload customer table. Let's check out our Apex application. We click on the review upload customer. You can see now there is a data appear here. And if you scroll to the last column, the credit predictions is already here in the last column. Let's take a look at the summary. In this case, you will see that there were like 40 customers with 100% probability of good credit and about 49 customers with about 49.6% of the probability of good credit. Let's see the overall credit profile. Similarly, but it's overall. you can see that about 12K customer with 100% probability, and then about 66K with probability of 1.2%. All right, now you are done this step. The next thing is you need to expose your machine learning model as a REST endpoint so that any other application can call and utilize the model running inside your autonomous database here. Okay, you go to SQL Workshop. You click on the RESTful services. On the left side, you click Model. Click Create Model. Then just put in your module name like predict credit. Your best part / credit /. Click Create Model. Then you click Create Template. This is why you need to provide the URI template, which in this case, I'm gonna use /wealth and /income. Next, create the handler. The method we are going to use here is get, and the source type is query1 row. We will then update with the SQL. All right, we click create handler. So now our URL is ready. Let's test it out. We want to test wealth equal to rich, and then income equal to 20K. It's supposed to return you as the good credit. Yep, you are doing good. The result returned as a good credit. Yep, that is the end of our machine learning on autonomous database live lab here. So now,
thanks, guys. I think we've had a couple of questions. Are there any more questions today before we finish the workshop? As mentioned, this workshop has been recorded and it will be shared with you following the event, so in the next couple of days. If there's anything that we haven't covered today, or if there's anything else you would like to ask, then please get in touch, and we look forward to seeing you at our next event. Thank you.